Let's talk about the cart rolling down the track. Here's my cart on a track. The cart rolls down the track. Sometimes when it hits the end stop there, it kind of jumps the track. So before you take data, always wiggle the cart to make sure it's in the track. This thing has to be in the center, and the wheels have to be in the wheel tracks. You'll know when it rolls freely. Other thing is, make sure your motion encoder light is on. This means you're taking data. If that's not on, you won't be taking data. Another thing to check to make sure is these barcodes here, they're zebra stripes, and these barcodes here, they're lined up with each other. And then at the other end here, the motion encoder, notice the zebra stripes are lined up with those zebra stripes. Okay, so our question was, how is the speed that the cart hits the end here related to the distance that the cart rolls down? Notice that my stop is at 112 centimeters, 113 centimeters, 114 centimeters, 115 centimeters. It's lined up with 115 centimeters. If I start my cart here at 95 centimeters, the distance that it rolls is 115 minus 95, or 20 centimeters. So let's talk about some of the data that you need to probably write down on paper or a whiteboard. So the start position of the track is 115 centimeters. The starting position is going to be 95, and the distance is 115 minus 95, or 5, 10, 15, 20 centimeters. We're going to use LabQuest to tell us how fast the cart hits the end stop. And here's how that works. I'm using this end of the cart that hit the end that hits the end stop, as kind of my reference point on the cart. So using my finger, I'm going to move that reference point to 95 centimeters. So here's 96, 94, 95. And I just want the end of the cart lined up with 95. I'm using my fingernail instead of my fingers just because I can pull my finger away pretty quickly and get it rolling. So now let's talk about LabQuest. LabQuest is going to record the time, the position, and the velocity or speed of the cart as soon as I start collecting data. You start collecting data by pressing the space bar. So let me see. If I press the space bar with my finger while I'm holding the camera, let's see. You can see that it's collecting data. Since the cart's not moving, the position is something constant, the velocity is 0. That's what I totally expect. But that's not what we're interested in. We want to see the cart moving. So I have my finger over here holding the cart. I'm going to press the space bar. You don't have to hurry up, you can just let it go. But once it hits, you want to press the space bar again to stop taking data, because we're going to focus on this now. Alright, so this is a graph of velocity versus time as the cart was moving. Notice here, the cart wasn't moving, and then the cart started moving, and then the speed of the cart got to some maximum value. That's what we want to record on our whiteboard here. So let me show you where that number shows up here. You have the velocity here in this column. Notice that the velocity starts at 0 and then increases, and at some point it's going to decrease rather quickly. So 0.31, 0.331, 0.346, those are meters per second, and then it's going to be 0.346. Notice that 0.337 is less than 0.346. So let me highlight it. That's the number that I'm going to write down on my table here. So 0.346. Always good to keep your decimal places straight. Always good to get your units straight. And that's meters per second. You probably want to take more trials to make sure that this number, you have some confidence in this number for when the cart rolls 20 centimeters, it has this velocity at the end. You can go from 105 to 115. I was going to go in tens, 85, 75, 65. Remember, we're trying to find the relationship between the distance that the cart rolls and the velocity that the cart has at the bottom of the ramp.